Ma'am, I saw the recording of the class on Thursday and I didn't understand a question you did in that.
Yes, Harsha.
Ma'am, I saw the recording of last Thursday and I didn't understand one of the questions you did in that.
The same question which you had the doubt.
Yes, ma'am.
Okay,
Cos
I'll discuss
WT
that.
plus.
Anyways,
Yes,
I
ma'am.
wanted to discuss it in the last class itself. You had an extra class, so you had to leave. That's why. In today's class, I'll discuss it throughout. Okay.
Oh, okay,
Technique
ma'am.
is very simple. You just have to double differentiate it. So I'll just tell you the technique, then you can solve it, and then you can let me know in the next class. Otherwise, if you want, I can send you proper solution written in WhatsApp also. Just let me know. First, we'll discuss it. Let us just complete a portion of this, then we'll discuss this.
Okay.
Yes, in the last class, we started with kinetic energy. So kinetic energy is both the formula we had seen with respect to as a function of position and as a function of time. Both we had seen. So kinetic energy as a function of time, it was half m omega square a square sine square omega t plus phi naught. Because velocity was omega under root a square minus x square. So kinetic energy was written as half m omega square under root a square minus x square to the power whole square. So when the squares are cancelled, that is half is multiplied to this 2, we obtain half m omega square a square minus x square. This is the function of position. Now, mean position, at mean position, x will be equal to 0. At extreme position, x will be equal to a. So kinetic energy will be half m omega square a square. There is the maximum value possible. And at the extreme position, kinetic energy will be 0. And kinetic energy cannot be negative. That's why this is the minimum value that is possible. Secondly, lastly, we saw the formula of potential energy, which was half kx square. How to derive half kx square? Derivation is already there in work energy and power. Now, x is equal to a cos omega t plus phi naught. So u is equal to, that is the potential energy. It is equal to half k a square cos square omega t plus phi naught. So this is the equation with respect to function of position. If you have to calculate it with respect to function of position. So half kx square will be with respect to function of position, and this equation will be with respect to function of time. Again, the same thing, when you put x equal to 0, you get the minimum value of potential energy. And when you put this x equal to a, you get the maximum value of potential energy. Minimum value here will also be 0. And at extreme position, the maximum value will be half k a square. This is the maximum value which is possible. Now, total energy was left. See, total energy is basically sum of kinetic energy and potential energy. Whenever we are talking about the total energy, it's not the internal energy of the system that you will include all the energies that are coming. When the term total energy is written, that means it's the sum of kinetic energy and potential energy only. When internal energy is written, then whatever energy is there present in your system, you consider it also. So that's why right now, when I'm saying kinetic energy, we are just talking about kinetic energy and the potential energy for the total energy. Now, total energy, this will be, kinetic energy will be half m omega square a square minus x square plus potential energy will be half k x square. All right. So it's like at a different time. See, if I'll open up this bracket, this is k, so half k a square minus half k x square plus half k x square. So I'll be just left with half k a square itself. That is the total energy which is coming. So how do we write the total energy? Through the graph. This is how it is drawn. See, this is an important graph. It's already mentioned in your NCRT also. You can check the graph from there also. Actually, it's the same graph, but in text, you can check it. See, this is the graph of kinetic energy. This is the graph of potential energy. Both are present. It's just because of the extreme position and the mean position that we are getting the graph. The minimum value here 0, then reaching the maximum value at mean position, again at extreme position it is becoming 0. That's why you have the kinetic energies graph like this. And for potential energy, just opposite. At the mean position it's 0, and at the both the extreme positions it is having some value. That's why some values are there at the extreme position, and at mean position it's 0. So both of their average is taken, which is the total energy. So this is not in the axis. Axis is here, x-axis. This is the y-axis with which is having energy. This is the total energy which is present. We'll see question also before we start with spring mass system. Write it down first.
Ma'am, in the equation, mw square is taken as k.
Mw square is taken as k, yes.
Okay.
Mw square is k. Omega's formula is this only.
Okay.
Omega, whenever we write in the second order, I'll discuss that also. Omega square is written as k by m. This is the formula of omega square. If you've seen the video, I think you must have witnessed this part. Omega square is equal to k by m. So from there only we are writing it. I'll discuss this also because that was missed. I'll discuss it. a body executes SHM of time period 8 seconds. If its mass be 0.1 kg, its velocity 1 seconds after it passes through its mean position be 4 meter per second. So you have to find the kinetic, potential and total. Okay. So see, time period is mentioned as 8 seconds. Mass is given as 0.1 kg. See, at t is equal to 1 seconds. Amplitude we do not know. Right, amplitude we have no idea. Amplitude is not mentioned. Velocity is given as 4 meter per second. See, x is equal to a sine omega t. This in the last class also I told you that for the mean position we are going to use this equation. Mean position. This equation is to be used for a mean position. Now v is equal to dx over dt. That is a omega cos omega t. We'll have velocity. See, when we have to calculate a omega cos omega t, so velocity is 4, amplitude we do not know. Omega, do we have? Yes, we know time period is 8. So omega will be 2 pi by 8 cos omega, and time is 1 second. So t is 1 second. That's it. So yeah, from here we can calculate further. See, 4 is equal to a into this becomes pi by 4 cos 2, that is again pi by 4, so which is 1 by root 2 cos 45. So this is 1 by root 2 into 1 is 1, so I'm not writing it again. So amplitude from here, this will be equal to 16 root 2 divided by pi. This is the equation or the value for the amplitude. This is for the amplitude. All right. Now the next step. When we have the amplitude, we can easily calculate the kinetic energy, total energy, potential energy, any type of energy when we are required to. See, total energy is half k a square. So total energy, this will be half. See, if half k is not given, we can write m omega square a square, because omega square is equal to k by m. So k will be omega multiplied to m. Mass is 0.5. Omega was 2 pi by 8. So pi by 4. So that becomes pi by 4 whole square. Amplitude also we have calculated 16 root 2 by pi. So this whole square also a square. So this is 16. This pi square and pi square will cancel. This 16 will cancel 116. So only 116 will be left. Root 2, this 2 will cancel this 2. So 16 into 0.1, that will be 1.6 joule. Just cross check also once you are writing. While you are writing, you can cross check this. Also, apart from this, for the kinetic energy, instead of calculating the whole thing, the best way is just divide total energy by 2. That gives you the kinetic energy. So simply this will be 0.8 joules. When we are calculating the potential energy, see, total energy is actually the sum of kinetic energy plus the potential energy. So you know total energy is 1.6 joules. Potential kinetic energy is 0.8 joules. So potential energy we do not know. So again, potential energy will also be 0.8 joules.
And both will be always equal.
Hmm?
And both will be always equal, kinetic energy and potential energy.
No, kinetic and potential may not be equal. Usually for the waves it is equal because of the formula half kx square. If this is matching, like in this question, see, it is having this time period, velocity was this, through its mean position it was given. right? This was given through its mean position. So here we had taken here kinetic energy came out to be 0.8, right? If kinetic energy is having a value, a different value, like here we had seen in the last class, kinetic energy, yeah, this was the value of kinetic energy, half m omega square a square, right? This value and this value, both the values are same in this, for this question, half m omega square a square, right? Here also it's half m omega square a square, and this is also half m omega square a square. This was for mean position here, and this was for the extreme position over here, right? So here we are not using this formula. For us, we are not using this formula, half m omega square a square. We have used this formula for kinetic energy. But because kinetic energy this time came out to be 0.8 joule, it's not necessary it will always come 0.8 joule.
Ma'am, then how can we say that the total energy divided by 2 is kinetic energy?
No, see, there's a formula for this. Kinetic energy is usually total energy divided by 2. Half of kinetic energy. This is because of this relation. See, total energy is this, half m omega square a square minus half m omega square x square plus half kx square, right? In this question, in this particular question, even if you do not take this is just for the calculation purpose. This is not, that's what I'm saying. This is not fixed. This is not something fixed which we take. If you go by all the relations which we have, potential energy has a relation with kinetic energy. Also, total energy is negative of potential energy. There are so many relations. This is not that relation which we take and consider it in atoms. Here, total energy came out to be 1.6 joules. See, this came because of half m omega square a square, right? This was because of half m omega square a square. Now, in this question, this is saying, if you go by the formula of kinetic energy, this is half m omega square a square, right? Both these are the same, half m omega square a square, and this is also half m omega square a square. Understood? This is because half kx square has been written. Since half kx square has been written, that's why we have taken that the total energy is being divided into two parts, because nothing else apart from that has been mentioned in the question. What the question is saying, it says that body executes SHM of time period 8 seconds, mass is given, velocity after 1 second you have to tell, after it passes through its mean position. That means mean position has already been crossed. Now, what is the exact state after mean position has been crossed? This is the extreme position. This is the mean position. Is it coming in between this? Is it exactly in the middle? This we have no information. So that's why we have equated it with 2. Even if you do not, you just go by the formula half k a square. Use this formula, half k a square. What will you get? You will get half m omega square a square if you go by the total energy formula. Here, what are we getting for these? A square minus x square for kinetic energy. Here you will be using the formula. For potential energy, you will be using the formula directly 0, because it was, I think, mean position or extreme.
And passes after the mean position.
Through its mean position, yes. So if it was mean position, potential energy directly would have been 0. Kinetic energy and total energy would have been equal. Right now, there is no information about, after this passing, we have no information about this angle that has been made. We do not have this, it's a vague question. We do not have information about this entire angle. Is it 90 degree? Has this extreme position reached? Or has this mean position been completely crossed? We just know that after it passes through the mean position. So since it's not exactly at the mean position, that's why we are not taking it 0. Otherwise, this would have been 0. Both of them would have been directly equal. Right now, we are seeing the total energy is being divided into two parts. Why? Because whatever is the change in the potential energy, here only kinetic energy was present as soon as the motion began, and as soon as the height was reached, wherever it has reached, we do not know, because that is not given in the question. Here we are getting potential energy. So since we do not have any information how much portion of total energy is being divided into kinetic energy and potential energy, that's why we are saying total energy half part is given to kinetic energy. So that's why directly I have written kinetic energy this. Total
And
energy is
you
this.
can also go by the formula, right? Of
You can go
kinetic
by the,
energy.
you have to go by the formula. You have to go by the formula. It's just that these things are usually not written like this. It's written whether it's at the mean position or extreme position, or if it's at a certain position, then the value of x has to be given. If you know the value of x, you will be able to solve the question by the formula, right? You just
Yes, ma'am.
need this x because we have no information about this half x square. It says that it has crossed the mean position. So if it has crossed the mean position, that what is the separation from the mean position, that is x. So since we are not completely aware of it, that's why I'm saying total energy we have divided into kinetic and potential. Understood?
Yes, ma'am.
Okay, write it down. Okay, now talking about the spring mass system, we have the oscillation of a loaded spring that also produces simple harmonic motion. So for that, you have to understand there are two arrangements of spring. One is horizontal spring. Horizontal springs, this is arranged like this. A spring is made and at the end a block is kept which is having mass m. Then you have the vertical spring. Vertical spring means this side is attached. Like here, this side is attached, here this side is attached. This is the mass m, this is the vertical spring. So basically the formula that we follow is the restoring force is directly proportional to the displacement from the mean position with a negative sign because restoring force is directed towards the mean position, which is in opposite direction. That's why this equation of SHM will remain the same. This is what we already know. What are the additional things? Omega is equal to under root K by M will be used here as well. So this formula also you should be aware of. One more thing, omega is 2 pi by t, which is equal to under root K by M. So time period will be equal to 2 pi under root M by K. So frequency will be equal to 1 by 2 pi because it's 1 by time period under root K by M. This is the formula of frequency which you should remember apart from this formula of time period also, that is 2 pi under root M by K. This K, what exactly is this K? This was the spring factor, that was the general one. See, if I'm talking about this K, this is the spring factor, which is different for different systems. But if I'm talking about specifically spring mass system, if spring mass system is given to you in the question, this becomes spring constant. And for different systems, you have different names attached to it. Question is also there. We'll see. First, write it down.
Ma'am, the K in W equals under root K by M is also a spring constant.
That was only the spring constant. Omega square is equal to K by M, which we have been writing throughout. That was only the spring constant. It's the spring constant, not spring. That is the spring constant, not the spring factor. For just don't go by the terminology. Spring factor, when I am saying it's spring factor, it means it can be anything, not just for only spring mass system. But when I say spring constant, that is specifically for spring mass system. So K is generalized constant. Every constant has a name. So this has a name as spring factor. But this factor means it can be anything. For time period, it's 2 pi because the formula is t is equal to 2 pi under root L by g, like this. Okay.
And so for the omega formula, it is spring factor.
Yes, for omega formula, it's spring factor. But when we are talking about spring mass system, this we call it as spring constant.
Okay.
For different system, this spring factor will be something else. For a different system, spring factor will be something else. So spring constant is specifically for spring mass system, but spring factor is a general term for just the constant. That was omega square into mass.
Okay. Ma'am, in F equals minus kx, it should be spring constant, right?
No. See, that's what I was saying. This is the general form. This is a general formula. It's a general equation of SHM. This is not, I'm not talking about the spring mass system right now. This is also a general formula. This is a general formula. So these are spring factors. Spring factors are different for different systems. For different systems, you will give it a separate name. But right now, when I'm talking about this I have written it as the general equation of a system. See, here, when I'm specifically talking about spring mass system here, all these, then I'll say this is spring constant.
Okay.
Understood?
Yes.
See, this says that a 5 kg collar is attached to a spring constant. See, now this is talking about spring constant. Spring constant means the spring factor is the constant of the spring mass system. That's why the term spring constant is being used. Spring factor is a bigger term. It's a bigger umbrella. Under that umbrella, you have smaller terms for different systems. Like you have simple pendulum system, you have spring mass system, you have U-shaped tube. These systems are included in your syllabus. Apart from this, you have lots of materials also. So 5 kg, 500 Newton, and position is 10 centimeter. We have to find time period, maximum speed, maximum acceleration. See, mass is 5 kg. K spring constant is 500 Newton per meter. X is 0.1 meters. That is the amplitude. So for the first part, time period, T is equal to 2 pi under root M by K. So T is equal to 2 pi under root 5 by 500. So 1 by 100, it would be 1 by 10. So this will be simply 2 pi
And
by
X
10.
is the amplitude?
Hmm?
X is the amplitude.
X is the separation from the mean position. This. The collar is displaced from its mean position by 10 centimeter and released. Means this. If this is exceeded by 10 centimeters and then it's released. So restoring force will push it back. Basically, the mechanism behind all these is external force pulls it. Suppose this was the resting position. Now I have pulled it. So this becomes X. So if I take it to the extreme, last position which is possible for the spring, beyond which spring cannot be extended, then X will be equal to the amplitude. This is what I was saying. Okay, because every time we cannot draw mean position like this, extreme position like this, and only call this as amplitude. In spring mass system, only stretching of spring is possible. So this is how we have the amplitude. Then the restoring force acts in our system. Restoring force tries to push it back towards the mean position. That's why in our equation also we have this negative sign present. So when it will come, suppose this is the last possible stage. Beyond this, spring cannot be extended, it cannot be exceeded because its elastic limit will be crossed. Then we'll say this is the amplitude. This is how we'll calculate the amplitude. Okay. So X will be equal to A here, X will be equal to 0 here. So coming back to the question, this time period will be pi by 5 seconds. Secondly, we have V is equal to omega under root A square minus X square. See, X equal to 0 for the mean position and X equal to the amplitude for the extreme position. So here we are talking about the maximum velocity. The question has asked us maximum speed. So we already know the formula for V max. That is omega A, because velocity is maximum at the mean position. So this becomes 0. We have omega A. This was done earlier itself. So velocity will be 2 pi by t into the amplitude. This time the amplitude for us will be x only. The value that is given, displacement from the mean position. Because for us, the spring mass system, we have the amplitude, which is the maximum displacement. So this will be 2 pi by t is pi by 5. This is 0.1. So 10 into 0.1, V max will be 1 meter per second. Lastly, we have the acceleration maximum. This is equal to minus omega square A. So acceleration is minus.
Could you explain the velocity part again?
Yes. See, velocity is omega A because this is the maximum. Velocity is maximum at the mean position. So x becomes equal to 0. If x, this term is 0. So we are left with omega under root A square. That is omega A. How do we write omega? Omega is equal to 2 pi by time period into the amplitude, right? So
Yes.
what is the amplitude mentioned in the question? That is maximum displacement from the mean position. This is given as 10 centimeters, which is 0.1 meters. So we have 2
So we'll
by,
consider the displacement as amplitude.
yes, for spring mass system, that's what I was saying. For us, the amplitude will be the separation from the mean position only, because every time we cannot have this pendulum system. This only will be there. X equal to 0 is at the mean position. Then you have x equal to amplitude. In between, if it lies. If it lies in between, then we will calculate it as something else. But right now, it has been completely displaced. Right? It is saying the collar is displaced from its equilibrium position by 10 centimeters and it's released. So it means this entire oscillation process has been done. Otherwise, it will mention you two things. If it's a different question, then you won't equate it to 0. If it's in between, if it is somewhere in between, it will tell you the value of the amplitude also. It will tell you the separation from the mean position to which it has been extended. Understood?
Yes, ma'am.
So then we get the value as 1. So omega square, omega is how much?
And
2
why did we
pi,
get 5?
5.
Yeah.
From here, time period is pi by 5. So pi by 5 will go up.
Okay.
Okay. So this is how much? 2 pi, we have omega is 2 pi by time period. That is 10. So 2 into 5 is 10. So 10 into 10 will be 100. So this will be minus 100 into 0.1, which is equal to minus 10 meter squared. So maximum acceleration is minus 10 meter per second square. All right, write it down. Question. Have you written the question?
Yes, ma'am.
Harsha, have you received your date sheet of the final exams of class 11?
Yes, ma'am.
So when are your exams starting?
Ma'am, the pre-boards are from Jan 18th and
Okay, 18 Jan.
practicals from
Mm-hmm.
February 1st and the finals from
In
February
11th
18th.
also you have the pre-boards in your school.
Yeah, ma'am.
Okay, so from 18 Jan. And what about the final exams?
February
Annual?
18th.
Yes?
Ma'am, February 18th.
Okay, 1 month
Yeah, ma'am.
after the pre-boards. Okay, okay, okay. So 18 Jan, fine, that is completed before that. Then we'll just have the revision and doubt classes. Okay, that will be
Okay.
helpful. Just let me know how do you want to proceed, Harsha.
Ma'am, this chapter will take more how many classes?
This chapter is towards the end. Spring mass system. This is very small. This just has one question, simple pendulum, because its derivation is already there from your that dimension analysis. Then YouTube is there. Forced oscillation is very small. It will just take one class. If you want one big class, also I can take 1 2 hour class that will complete this lesson. One or
Okay.
two classes it will take.
Okay.
Okay, that's why I wanted to know your schedule, because it's 4th Jan today, so next week we should be able to. But revision classes also we should have revision classes. How is Krishna, Harsha? What is he doing?
Ma'am, he joined in Delhi JNU University.
He's in JNU.
Yeah, ma'am.
Okay, so he's in Delhi. When did he come?
Um, he's like he came recently, 2 weeks back. His flight back is on 10th again.
So what is he doing? Which course?
CSC, ma'am.
Okay, okay. It's good then.
Okay. Thank you, ma'am.
Okay, Harsha, that question, no?
Yeah.
See, I'll just tell you the method once. Then to identify periodic motion, non-periodic motion, that becomes a question to deal with. So
Ma'am,
let's.
I like saw the recording. I
Mhm.
understood most of it. But ma'am, how did we get the relation that double differentiation is proportional to x or y?
This relation.
Yes, ma'am.
How did we get this? This has a very lengthy derivation. You don't need to go into the details. This is like a shortcut, which you should remember.
Ma'am,
Even in
like
your
in short,
class 12th NCRT books or any books, this is not included. It's a very, very lengthy derivation, which has some constant and integrations, which are also not just part of your class 11th. That will take portions of 12th also. So that's why we don't discuss these derivation in detail. We don't have these derivations. I just wrote this directly, right? I've just written it directly. This we have the equation. I told you this is the second order differential equation, which we call it second order differential. How obtain this? This is important. Starting from here, f is equal to minus kx, then acceleration, and then double order differential equation. From here, when we are talking about, you should just remember how to check periodic, non-periodic. By just cos and sine will work. For periodic and SHM, you have to confirm, and the conditions of SHM will be helpful. Their combinations will tell you that it's periodic or non-periodic. So it will help you segregate non-periodic. For SHM, this is the best method which you should do, because you will not get stuck anywhere in these. The questions
so
will
in the
also be simple.
exam we can directly state that.
Directly write it. See,
Okay.
do not start with this. Start with the differentiation part. Differentiate it again, double differentiate it. Finally, you will see whatever constants are left with some term y, like this. Then just put this is d square y or dx, whichever variable is given, is equal to k x or y minus kx, like this. Then see, this is directly proportional to this. This actually comes from the starting of this derivation is from here only, f is equal to minus kx. Then we differentiate it, and then integrations are also involved, from which we get a constant also. Then that is a long derivation that you can skip. So from, and some portions were, this was done through experiment. So this has no derivation, but these derivations are started from here. That's why we get this equation similar to it. Then you will straight away write second order differential equation is directly proportional to this, because this is included in your class 12. This is not something shortcut which is just present that you have to mention. So in your final exam also you can include it very well.
Okay. Is it
Okay.
also proportional to omega square?
What?
Is it also proportional to omega square?
It is proportional to omega square as well, yes. This is proportional to omega square, but multiplied to mass, not just omega square. Product of omega square and m.
There was a question in which in the final product there was omega square, but it wasn't SHM. I didn't get that question.
Omega square was coming, but was there any x? Was this equation satisfied? This
It's
or
like in
this?
the recording only.
Which question then?
Cos WT plus 2 sin square WT.
This one?
No, ma'am. After that. Yeah, on this one.
Which one?
Yeah, this one.
This
Cos
one.
WT. Yes.
So here this equation is not being satisfied. No. Okay, you are asking if it is directly, this you are asking. D square omega dt, if it is directly proportional to omega square, is it satisfying? This you are asking?
Yes, ma'am.
No. See, if this is there along with y, this has to be present. D square y dt, not just omega square. Not just omega square. This has to be present omega square. If it is present with y, then only it is called as SHM. Like in this question, after all the differentiation, double differentiation, differentiations will also be very easy. You just have to take out omega first, learn from for cos, learn for sine, just reciprocate it for the double differentiation. You get these equations only back, but with negative and positive sign. Here, y is completely eliminated. So this is not done. Only with just this, you do not have it. There is no connection with it. If it's
Okay.
minus omega square y, then you can say. Okay.
Okay.
Okay, Harsha, then next class, let's continue.
Okay.
Okay, thank you so much.